name's Steve Zitney. I'm head up the Process and Dynamic Systems Research Group at the National Energy Technology Laboratory, or NETL for short. The U.S., in terms of coal supplies, we probably have over a 250-year supply of coal based on current usage, so I envision that coal will continue to be an important part of the U.S. energy portfolio, and gasification technology is very well suited to making use of coal, especially in a carbon capture type of scenario. The Department of Energy has an overarching goal to develop innovative gasification-based technologies with 90% CO2 capture, and this project was initiated really to get at that goal in terms of the operations and control of these advanced energy plants with CO2 capture. We were looking to use the IGCC simulator to establish a research and training center at NETL and West Virginia University for use in training engineers and operators on the operations and control of these advanced power plants with CO2 capture.
My name is Richard Turton. I'm a professor of chemical engineering at West Virginia University, and I've been working with the Department of Energy for about the last 5 years in the area of simulating both steady state and dynamic processes associated with fossil fuel plants. The benefits to the university by me working on a project like this are that I believe that I can bring this sort of technology to a new generation of students, and also really this whole concept of operator training and the idea of sort of having a simulated control room and being able to sort of operate a virtual plant.
It's been a collaboration amongst a number of different project partners. I mentioned West Virginia University from the academic side, of course, Advanced Operations Management on software development, and we've brought in a number of consulting partners that have quite a bit of IGCC operations and control expertise.
I think in terms of the classroom teaching and the education, there's a sort of really an infinite amount of information that becomes available to students that's just not available in traditional teaching methods that we use. So, you know, for example, most of the control experiments or the control case studies that are used at the university are really quite simple. They involve maybe looking at the dynamics of a stirred tank or something like this. With the operator training system, you have the ability to look at a whole process, look at the sort of full dynamics of distillation columns, pumps, vessels, heat exchangers interacting with each other, and that's just an opportunity that is not available currently.
The operator training system was developed using software from Invensys Operations Management. There are a number of packages that have been brought together to deliver the overall OTS for the underlying dynamic model, the plant-wide IGCC, CO2 capture, the power side, the combined cycle side. We've been making use of the DynSim software package. In addition, as part of the OTS system, we have the HMI software, the human-machine interface software that the operator trainees will interact with. That was all built on top of the InTouch software, also from Invensys. One thing I like to point out, this is the first time we're really bringing together a gasification-based simulator with CO2 capture and combining that with a power simulator, a combined cycle simulator. So it's more or less combining almost a chemical plant with a power plant.
To me, I think there's a massive link now between the sort of way students think and some of the things that are being brought online now, especially with the operator training system and with the additional immersive training part, which is a sort of 3D virtual environment that sort of communicates with the operator training system.
The OTS that we've developed as part of this project is a high-fidelity simulator. So we can go through entire IGCC plant startup, shutdown. We can look at what's happening in terms of disturbances, malfunctions, look at load followings. We can do full plant shutdown, including emergency shutdown. We can also look at coal changeover, switchover, so the simulator can handle a variety of different coals, all the way from bituminous coals, sub-bituminous, up to petcoke as well, and also a number of different biomass feedstocks. So even individual plant sections, for example, the air separation unit, the CO2 captures unit there, we can use those standalone units and really give detailed training and do detailed engineering studies on those specific technologies as well. The dynamics gives you a lot of insights into the overall plant operations and gain a lot more knowledge beyond just conventional steady state type modeling that would traditionally be done in terms of designing these systems. In addition to the operator training system, we're also developing a full 3D virtual immersive training system as well, or an ITS, and so that will be a full plant walkthrough type model that will be directly connected to the dynamic simulator, the operator training system, and will allow us to do sort of joint control room and field operator training. So the field operators will be able to walk through the plant in the 3D world and can walk up to a piece of equipment like a valve, close the valve. It will close it in the operator training system, so the engineers working in the control room will see those changes. A lot of the equipment can be made transparent, so you can see what's going on dynamically within a given piece of equipment. And in this project, we're really focusing a lot on the gasification technology, CO2 capture technology, and the ITS will allow us to further highlight those technologies. For example, in the gasifier, we'll more or less be able to look inside the gasifier. You can see animations of the slag flowing down the gasifier that's tied live to sort of the slag viscosity and the underlying dynamic model. So we intend to make use of this simulator in educational settings as well, and senior process design courses, control courses.
When I was going to school, a lot of students, it was standard for us to go on many plant trips. Now that's somewhat rare. I mean, the number of plant trips that students seem to take is somewhat less. The immersive training environment actually gives students the ability to go on a plant tour in the virtual environment. As a teacher, it also gives me the opportunity to actually explain to them in far greater detail that you can ever do in a real plant trip of exactly why the equipment is set up like this, where the interactions are, how each piece of equipment operates in a given process. So it's just a brilliant learning tool. I mean, to me, has been just an eye-opening experience.
This simulator will give us a lot more experience with the operation and control of these systems, and will position us well for the future in terms of using coal systems, and especially clean coal systems, where we need to capture the CO2 for storage to avoid the emissions. So I think this simulator is very important in that regard.
I've been very fortunate, I think, to be involved in this, and look forward to sort of continuing collaboration both with the Department of Energy and Inventus. It's a great project, and I'm very fortunate to have been involved with it.